Everyone, and welcome to this Common Europe webinar in association and sponsorship from Rocket Software. We'll start in a couple of minutes. People are just starting to join. We have 6 attendees at the moment, and there are quite a few others that have registered. So we'll just give them a moment. So just do bear with us, and we'll commence in a couple of minutes. Thank you. Okay, so I see people are starting to join. So permit me, just before I hand over to Andrew, who's your presenter today, permit me just a couple of moments to talk about Common Europe, what we do, and some of the events coming up. So a very good and warm welcome to you all. On the next slide, you can see there just a little overview of who we are. We're an umbrella organization. It says consisting of 18 European user groups. We're actually 19 now. We do keep expanding, and there are a couple of other countries in the pipeline that hopefully will join in the next year or two. So we represent Power Systems, IBM, AIX, and Linux, and our mission is to advance the professional development of our community through educational activities. So on the next slide, you'll see that we do have several events throughout the year. Participated in the IBM Tech Exchange recently. We have occasional hackathons and workshops, and these webinars, of course, which are all year round. So indeed, if you are interested yourself in hosting a webinar, please do get in touch. Our flagship event, which is coming up next June in Lyon in France, is the Common Europe Congress. So save the date, it's the 14th to the 17th of June, and it's a great opportunity to get some free education, network particularly. The networking is usually very nice. So watch your mailboxes or check out our website for details on the Congress and all other events and information. But just a quick mention to the Common Europe Advisory Council, also known as SEAC. This is quite important for us. It's a group of European technical experts from our user groups that meet with IBM developers, and they discuss current and future strategies with them. So it's a very important and productive council that we have there. Next Gen, this is aimed at offering networking and educational opportunities for students and young professionals, basically to help shape the future of Common Europe and the platform that we represent. So again, if you're under 35 and you'd like to be involved, do get in touch with Common Europe. Okay, so just on the next slide there, just see that if you have any questions or you want to make any comments, then just drop them in the chat, and Andrew, our host, will happily respond to you at the end of his presentation. So without further ado, I shall hand you over to Andrew Simpson, Rocket, and enjoy the presentation. Andrew, it's all yours.
Okay, thank you very much, and good morning, everybody. Thanks for attending. Today, we're going to be talking about data replication, specifically from your IBM I to pretty much anywhere you like, whether that's in the cloud or whether that's to a Postgres or an SQL Server database, or you might want to stream your data. So we'll be covering all topics regarding data replication. My name's Andrew Simpson. I'm a solution architect at Rocket Software. I've been here for 21 years now at Rocket. I'm an ex-IBM I developer. Started off back in the day on RPG3. I had to do some RPG2 as well, which was painful on System 36. But yeah, today I'm now a solutions architect. But yeah, been working on the IBM I system ever since I went on work experience in 1988 to one of the first companies in the UK that had an AS400. So we're going to talk about data replication, as I mentioned. We're going to do a brief introduction, and then we'll talk about the data replication that's available. We're also going to cover something called business logic rich APIs, and I'll explain the reason for that shortly. Any questions and answers, obviously we'll cover. You can just ask a question in the chat as we go along, and then I'm going to do a demo at the end, and I'll show you a real life demo doing some data replication or some CDC, and also which is change data capture, and also to cover some business logic APIs. So as you know, IT is expected to do more with less budget, and obviously there's lots of aggressive IT goals and business goals these days, and as you know, there's a shrinking knowledge base for the IBM I and Z platform, and what Rocket can do is they can help you by providing various solutions to enable you to do essentially more for less. So when we're talking about data replication, a lot of companies still do that manually or use ETL processes, and what Rocket can do is replace those processes with a one-stop shop for all your data replication needs, no matter whether you're bringing data into your IBM I, moving data out of your IBM I, or synchronizing backwards and forwards to your IBM I and distributed platforms. This is the IBM I business view from Rocket. So these are the areas of the pie that we cover, ranging from performance to business continuity to security and DevOps. But today we're going to be looking at API and the data economy, specifically through data replication. And as you know, different companies have different data strategies. So at the top there is coexistence. You're basically synchronizing your IBM I system, whether it's an ERP system or a merchandising system or a replenishment system, and you want to be able to replicate that data to distributed and cloud platforms in real time. So typically what you used to be able to do was, and companies still do this, is they will extract the data, they will transform the data and then load that, and it could be an RPG program to extract that data, and then you'll FTP that over to a staging server where it's then processed, and then you will then load that into your target platform. And of course there are other software vendors that can help with that to automate that process as well. Companies also talk to us about some sort of migration. There's no denying that companies are moving off IBM I. They're not moving off entirely, so they're using IBM I as their core strategic data source, but they might be migrating some applications off. And of course you want to keep that data synchronized between your IBM I as your core system and those distributed platforms where you might be purchasing additional applications. So for example, banks, for example, will buy an off-the-shelf loan processing application, but they'll still want to be able to amend the loan and take payments on their legacy platform as well. And then you're looking through modernization, so just using modernization through cloud and streaming technologies. Again, you might want to use things like cloud-based technologies for you could be saving the data to it for a cheaper way of storage. So to have a cold standby, and obviously looking at new technologies like Databricks, for example, which could be quite interesting as well. And then you've got the digitalization side, so putting it into data lakes and data hubs. So this is where your AI and ML will be coming into play, and obviously building large data lakes for analytical purposes. And the problem with analytics at the moment is because the data goes stale, then companies are continuously having to batch load the data back in, and you want to look for some sort of real-time data solution to push that data into your analytical cloud. So this is on the right-hand side here, we've got our I and Z systems, and then through data movement and also through APIs to enrich that data, we can then push that data into your data lakes, AI, ML, pretty much anywhere that you like to put that data. And obviously it then goes into some sort of storage. So whether it's S3 storage in Amazon, or whether it's Google Cloud, Azure, or some other third-party storage provider. it's all going to some sort of storage, essentially. So we're going to talk about data replicate and sync. So replicate and synchronize your IBMI and Z and distributed data sources to pretty much any place, anywhere. So Rocket continues to develop the solution, and as new data targets become available, then obviously we would be looking to include those as well. But looking at the diagram at the moment, primarily this product started on this solution started on the mainframe, but essentially distributed data sources, including the IBMI for DB2 for IBMI, are equally as important as well. So whilst we cover the mainframe very strongly and all the different data sources on the mainframe, certainly on distributed and IBMI, where we're very good as well. And we use a capture, transform, and apply process. So it's all done on the same server. So that could be running on something like Red Hat, which is a Linux based, and it could be in the cloud or it could be on premise. You tend to put the replication server close to your main data source for latency reasons. And in that, we can build a repository. So the repository will contain the database tables. And the nice thing about a repository view is that you define the data source, the data table once, and then obviously you can replicate that many times. And in there, you can specify your metadata, any process flows, any filtering you might want to do, any data transformation. And then you've got your targets as well. So for example, you could take your IBMI data and actually put it on a mainframe if you wanted to. You could take your mainframe data and put it onto an IBMI. You could take your IBMI data and stream it to Kafka, or you could even use MQ or other streaming method. And you can also use that same data to put it in the cloud. So if you want to use something like Snowflake, for example, which is a very popular database, which has got a very good AI and ML models inside it, then you can use that to manipulate your data as well. So simple replication and synchronization of your IBM data. There's no custom programming required. I mean, of course, if you want to do some transformation, you can write code if you want to, or you can look up to decode data, for example. But generally, there's no custom programming required for basic data mapping. It's secure. So what we tend to use is we use the native drivers. So for example, if you're talking to Snowflake, we use the native driver rather than the JDBC driver, and that makes sure that we get a full acknowledgement that the record has been written, and also that we're using the latest encryption. So for example, Snowflake uses client-side certificates, you can use SSO and things like that. And it also makes sure that we're using the latest security from a connectivity point of view as well. Real-time synchronization, as I mentioned. We've got the initial load, and then we've got the change data capture, which I'll talk about in a minute. And then we've got the performance and scale. So obviously we're taking advantage of any raw formats that we can use, and we can limit TCP/IP bandwidth by utilizing compression and things like that. And we've also got batch capability to allow you to scale for the initial bulk load. So if you've got like billions of transactions for a certain table that needs copying over, then we can set our batching capabilities to scale. We've also got a very good reliability and maintainability side. So we know exactly from a CDC point of view what record we're at. If there's been a comms failure or some sort of network failure normally, or the cloud has gone down, like Amazon Web Services went down a few weeks ago, then we can resume without you having to worry about exactly where we are in the record set and what CDC record has been applied and so on and so forth. So that gives you referential consistency. So the capture methods, as I mentioned, was bulk transfer. So this is your one-off load. You wouldn't want to bulk transfer every night if you have got transactional data that you were sending over. So this is an ideal for your initial load. And then you've got something called batch compare, which is quite nice. So if you do a lot of system testing, what you can do is you can do a before and after image, and you can get the deltas. So again, that's more of something useful for testing purposes, or if you want to compare data from last night to tonight, and so on and so forth after a series of programs have run maybe. We do archive log files as well, if you want to look at log files as well as synchronizing those. But most importantly as well is the real time. So this is a near real time CDC. So on the IBMI, we use something called DB2 Connect, and DB2 Connect allows us to connect to the journals on your IBMI. So it uses journals and journals receivers, and it's basically getting the information directly from those journals. They call it the active log, but yeah, it's journals that are actually doing that as well. It's also agentless, so there's nothing to install on the IBMI itself. And as I mentioned, we use DB2 Connect, which can be configured via the CLI command line very, very easily in about 2 or 3 minutes. So I'm going to talk to you about business logic APIs. So as we know, we create APIs for a lot of reasons. Here's some of the reasons here, and APIs is nothing new. But the whole idea of an API is you feed it with some information and it will give you back something important. So for example, if you were to feed an API with a customer number, it will return the customer's name, address, telephone number, account balance, and so on and so forth. However, what you can also do is you can use those APIs within data replication, or you can build new APIs using Rocket API to be able to do that. Or you can use your own third-party APIs as well. So what this enables you to do is you can build APIs quickly and easily. And what we can do is we can build those APIs across your RPG, COBOL, and various programs, C programs, in fact. We did this recently with a C program for a customer. And what we're able to do is we're able to unlock the business logic in your programs, and then we can use that business logic to then enrich your data that's being then used to replicate. And I'll show you a demo shortly on how to achieve that. We can integrate at screen level. So for example, if you've got a screen-based application that has a lot of business logic in it that displays values that are not in the database, then what we can do is we can take that data from the screens and we can create an API with it. But we can also do it at program level where you don't have any screens. So for example, you may have an RPG program that passes back a complex structure. And again, you may want to use the data from that structure to enrich your data, which you may then want to CDC over to a cloud-based technology. And we can also do that at database level. So if you've got a DB, well, you will have a DB2 database on your IBMI, and you want to replicate that as well, then you can also get access to the data through that, although RDRS already accesses the data in the first place. So from a screen level and a program level, unlocking business logic, this could be very important. You can create microflows, which is basically a discrete service, and you can also create a workflow. So for example, if you've got 3 or 4 steps of collecting data, or you want to run a process to be able to take data from different sources, so it could be 3 or 4 programs, for example, and you want to be able to create a composite response, then you can also do that as well. There's a central management and deployment for secure deployment and rollback. And also we do change management. So if the green screen changes, then your APIs automatically pick up the latest changes from the green screens as well. This is what it looks like, the architecture. So you've got your different clients. So this would be RDRS, essentially would be taking data from the API engine. And then you've got your different connectivities to your different systems. So this would be IBMI or direct program access IBMI. And then we can manage, monitor, and secure those APIs as well. So, any questions at all before I go to a demo? Don't think so. Do you see any questions at all, Jonathan? I can't see any.
There is in the questions. Ivanik says Gen 2.
Do you support Azure storage? Yes, we do. Yes, we do. Yeah. Yeah. So yeah, from a Azure storage point of view, whether it's Gen 1 or Gen 2, we support both of those as well. Yeah. I'll keep the questions up as well so I can see them. Okay. So this is my RDRS server. So Rocket Data Replicate and Sync. RDRS is a lot easier to say. So let's have a look at what it looks like. So this is the dashboard. And again, you don't have to use the dashboard, but we all like a GUI. So from that perspective, you can actually run it through the command line if you want to, a bit like you would run DB2 Connect through the command line or any database. But I'm obviously running it through the GUI. So we have something called an agent, and that basically is your repository that stores all your rules and what databases you're replicating and so on and so forth. And then you've got your data sources. So for example, this is an IBMI, and in here it's just a connect string. So all it is give it a name, tell it what database you want to connect to. So that would have been set up by DB2 Connect through the CLI. It needs a username and password that has access to the relevant permissions. So if you haven't, then change obj to change your permissions, and then you select the platform. So for DB2, obviously we could do mainframe as well, but it's DB2 I series. And you can have two systems. I've got two IBMIs. Why not? And again, you can see it's just a different database name. So once you've actually done that, you can actually specify your output targets. So for example, I've got AWS Postgres, I've got Kafka, which is a streaming service. I've got a local Postgres. I even output to an IBMI. I've got Snowflake, and I've got SQL Server 2020. And again, it looks exactly the same. So again, you're just putting through the connection properties. And obviously you can always test the connection as well to make sure it works. And again, if you're taking something like Snowflake, which is a little bit more involved, then obviously you need to specify your schema, you need to specify your data warehouse, because obviously we use virtual data warehouses with Snowflake, and obviously the database name as well. And then if you're using a streaming service like Kafka, this is actually running on an IBMI, this Kafka, running on the paste partition. All you do is you specify that whether you want JSON or Avro, because don't forget that Kafka supports Avro as well, which is a more rigid version. It documents basically REST. Avro does, a bit like a SOAP service used to. And then obviously specify the layer, which is Kafka, and then specify the broker address. And you can use Confluent as well with this, and you specify the topic as well. And then what happens, you've got your output objects. Sorry, these are the input objects rather. So these are the tables that I've selected from my IBMI. So you can see in here, for example, that I've mapped car B01, which is a car rental system. This is the IBMI table, license, brand, model, mileage, category. I don't know what that one is. And you can see here that I'm mapping that to AWS Postgres and my local Postgres as well. And if I look at this one, this is probably the one I have the most mappings. This one here, I'm taking, this is the car rental contracts from IBMI, and we're sending that out to AWS. We're sending it out to Kafka, and we're also doing it to my local Postgres, doing it to Snowflake, and to SQL Server as well. And to create one of these, to replicate it automatically, you just basically do this here and say, I want to take the replication path that's using to Postgres, and I want to send it to SQL Server, and it will automatically do all the linkage and mapping and everything for you. It will also deal with data types like packed decimals, and as you know, packed decimals is an IBMI thing. It will deal with that as well and do all your data mappings. But if you do feel that you want to go and change something, you can literally click on it, and you can actually specify a list of properties that you can actually change. So for example, if you don't like the data type, you can actually go through and specify what data type you like. And if you want to see what the DDL looks like as well on the target system, you can click on here, and the DDL is automatically created for you. So here you can see that we've got a schema name, and it's going to create the table name. And if you don't want to use the same table name, you can even rename it if you want to. And this is the SQL statement for creating the table. And then obviously we're adding a primary key there to match what the IBMI got. But as you can see, it creates all this for you automatically. And then obviously these are the outputs objects, so you can see by database type what your output objects look like. For example, with Snowflake, I only use two tables. I use a customer file and I use the car rental contract file. SQL Server, I'm only interested in this one. Whereas AWS, I'm actually mapping across every table on the car rental application. And then what you can also do then is you can create your bulk load definitions. So for example, I do it by database target. I mean, you could do it to say, send it to all of your multiple targets if you want to, but I like to keep them separate. So for example, I can see here, I'm loading the car demo system into my AWS Postgres. So here you can see my IBMI libraries, and you can see in here the different database tables. Yeah, it's even doing the CL, which is I didn't need to do those, but I've just selected everything. But yeah, and then you can specify which targets you're going to be sending that data to. And you can also then say, I want to specifically just send it to one target, and I don't want to do everything. But you could have done everything as well, and you could just have one bulk load that shoots your data off to 5 different destinations if you really want to. And then you've got your CDC, your change data capture. So again, for Postgres, for AWS, all you're doing is to specify what the data source is. So this is my IBMI. You're not specifying any tables anymore because it's looking at your journals. So it looks at your journals as a whole, and it's only ever interested in the tables that you want to replicate anyway. So for example, if for AWS I was only replicating one table, then it would only replicate one, even though the journals are actually tracking the changes for 5 or 6 tables as well. And then you've got the processes that are actually running, and here they are down here. So if we look at the Kafka one, you can see here that we had 187 records so far, and you can even see a little dashboard of everything that's running. So that's what happens, the little speedo starts moving as data comes in and is actually transformed. And you can also see whether it's an update or an insert as well. And you can see here, this has been running for 3 days, IBM DB2 near real time, 187 records. So it's 187 records and 10 CDCs. And if you look down at here, this is the actual writing to the target. And again, we've got the little speedo. So you can actually sit there and you can actually see how many records per second are being processed. And as you can see at the moment, there's not a lot being processed because I'm not doing anything. And you can see there's been 2 inserts and 4 updates to Kafka. And again, if I look at SQL Server, I can see the same for SQL Server as well. So SQL Server, I can see there's been 2 inserts and 3 updates. It keeps them jumping back up because it's refreshing, because obviously this is live. And then if I want to see something where I'm writing a lot of data, you can see here that that one's just AWS is see it's going on and off. My connection to AWS is going up and down, so it'll come back again in a minute. So it's probably a comms problem, but we'll just look at the local one here. You see here, you can see that there's actually 1, 2, 3, 4, 5 tables, and you can see here the bottom one in particular. There's been 256 records. There's been 301 deletes as well. 554 in total, and you can see the CRUD, basically the stats on the CRUD: create, read, update, and delete. I see AWS has come back now. See, automatically, I must have had a comms problem, and AWS is now back online again now. So it automatically see, it said the service was unknown for a bit, so it looked like there was a DNS problem for a short while. So what I'm going to do, I'm going to show you some database tables. So this is Postgres. So you can see in here that essentially I've got my IBMI, and this is the car rental application, which is on the IBMI system. And if I go and view the data, I can actually see all the rows for that table. And again, if I was to go onto the IBMI, essentially, let's go and sign in. Oops. So that's select star from carlib car B02. There you go. So Mr. Smith's at the top there. Not quite sure what order. There's a slightly different keyed order. But usually, there it is, Mr. Smith. There you go. And there's the data in Postgres, and here's SQL Server as well. So if I go into SQL Server, I'm actually just bringing up car rental contract 95 here, and as you can see there's the record for that particular one. And again, if I come in here, this is Snowflake, and if I run that for Snowflake works slightly different because you can't actually do a CRUD. So I have to basically do an operation to say this is an insert, a write, an update, or delete. But you can see the last record, which was written this morning at 9:39, is for 190 euros for this car rental contract. And we've also got Kafka running as well. So here we are, here's Kafka. So the last change I made was obviously the one I mentioned at 9:39 this morning, and I changed this car rental contract, 95 to 190 euros. So let's go and make a change. So let's just go and sign off. Oh, by the way, just to show you one other thing, which if you're wondering about the journals, it's just simple journal commands. So create journal and then start journal physical file, and then that will enable you to do the CDC through RDRS. So very, very easy to set up as if you were doing it. You do need to set some journal options here. So it's job, user, PUGM, and LUW. But yeah, that's just a one-off one there. Okay, so let's just sign off. So I'm going to log into the car demo. This is a car rental system. So in here, we have a list of car rental contracts. So I'm just going to bring one up, which is 95. So I'm just going to simply change the tariff per day. So at the moment it's 195, and I'm going to change it to 225. Okay, you hit enter. Okay, so let's see what's happened. So the first thing you noticed is we've got a new Kafka record. So it's streamed that to Kafka, and as you can see, the rental contract is now showing a tariff of 225. And if we go through to Postgres, I'll just run my query just for one record. So it's currently 190, and if I do a refresh, it's over to the right, it's now 225. And then if we do Snowflake, okay, and we go with Snowflake, you can see that Snowflake is now showing 225. It was 190, it's been 180, 145, 140. Snowflake obviously keeps the entire history because obviously we have to do the operation to send in the records. You get all the history. And then obviously we've got SQL Server as well. So again, there we go, 225. So as you can see, that's all replicated nicely. And it's as near real time as you can get. Bearing in mind, we've got to pick the record up and then send it over to the target system. So comms and everything being equal, it's as real time as you can get. Okay, so what I want to show you now is I want to show you some business logic APIs. So as I mentioned about the business logic APIs, we can essentially create a screen-based transaction that can unlock data from your IBMI and put it into a table, which RDRS will then replicate to your target system. So you can get quite complicated with this by creating some sort of workflow, as I mentioned, and I'll just show you a workflow, which is just going to load up in a second. Okay, so this is a workflow here, and what it does is, first thing it does is it deletes all the records on the database table. So you probably saw in my streaming, these are inserts, but there's some deletes as well. So every time I run this process, the first thing it does is it deletes all the records and then it reinserts them again. So that's what it's doing there. And then what I do is I read in all the car rental contracts. So I'll just read that from a DB2 table. And then for each car rental contract, I get some booking details, and that just comes from a database table. And then what I do is I run a screen-based transaction that goes into the car rental contract. So what it basically does is it puts a number 2 in, it puts the car rental contract in, presses enter, and what it does is it picks up some data from the screen, and that's what that stage is doing there. And then what it does is it writes that out to a database table on the IBMI, and that does that for every car rental contract and repeats that process. So I'm going to run that. It's just a REST service. And I'm just going to go and run my service. So this is all live, what we're doing. So hopefully it will start up okay. So I'm running my API engine now. Okay, now a green screen has appeared. This is just in show mode, and you'll be able to see the green screen processing some transactions in a minute. It doesn't do that really in live, but it's just for show purposes. And then I'm going to run this transaction. So it's this one here, I think. Get the right one. Rate extended. Not that one. I got the wrong service. That one there. Okay, so I'm going to run this. It's got no parameters because it's going to run every car rental contract. And then I'm just going to basically put everything in an order that we can see what's going on. So I'm just going to put that down there, the bottom there, so you can see it's streaming on Kafka. Okay, and then I'm just going to press execute. Okay, there we go. Okay, so it's now running. Now you can see. There we go. So you can see there's a lot of, there's a delete running actually. There's a delete. So we're playing this because we're streaming to Kafka. This is obviously streaming a record at a time. Now you can see what's happening in the left-hand corner here. It's going for every contract, but Kafka's still doing the deletes because obviously this is a streaming service. So it's basically writing one record at a time. But what's happening is the workflow, the macro, as you may want to call it, is running on the IBMI. It's now picking that data up. It's writing it out to this database table, and then RDRS will then pick up that data and it will start streaming it to Kafka. And you can already see, here's the inserts going on now. And you can see that it's inserting those rental contracts. And if I click one of those, you can see this is called RDRS Combine, which is the database table. And it's got a combination of the data and also the screen-based data that I've captured. So that's doing that real time. So for example, we have an insurance company that we've been working with, and every night they run through every policy, and then they run a screen-based transaction to basically get through the risks of the screens. And basically the risk can be, for example, you live near a lake, there's a chance of flooding, there's been subsidence, and so on and so forth for house insurance. And then what we do is we write that out into a new database table. RDRS then syncs that into the cloud, and then they use that data to analyze their risks for their policies through some machine learning. And then what they can also do then is actually manipulate data and then send that back to their IBMI later on. So this is still running, and this will continue running. As you can see echoing out on my console here. You see it's writing, it says contract added, and then it runs a screen transaction. It then writes to the database table, and then it does the next one and the next one. We could have multi-threaded this as well and made it a lot faster, but it's just doing one transaction at a time, just for good demo purposes. And that'll continue running now until the transaction has completed. So just looking at some questions, do you support using relative record number for CDC? Yes, we do. Doesn't matter because it's using journals. So from that perspective, we're using the journal receivers. So if you do an update, and that update is to change something for record number 256, and that's then journaled to the journal receiver, we'll just pick that up and then process it. So it doesn't need keys to be able to process it. All it needs is the journal to be able to do it. Can your replication software run on premise, or is it cloud-based? No, you can run it on premise. So we run this on mainframes, for example, and people will run this on the Linux partition on the mainframe on premise. And what that does is it keeps the latency nice and low. So when you're talking to the mainframe, you've got the RDRS server really close. This instance I'm running here, it's just running on a VMware in our data center it's in Amsterdam, I think. But yeah, you can run it on premise or you can run it in the cloud. It's entirely up to you where you run it. So that's finished now, as you can see. It's now completed the last record. So I think the last record number was 202 to 2025-047. Oh, it was 048. It's probably at the bottom of the log. So yeah, and there's the last one there. So you can see that it's finished processing and all those records have been processed. And all that was is there's just another database table. So on the IBMI, I showed you car B02 earlier. So I just sign in. Oops, I always do that and put the bracket at the end. So I'll have a look. So RDRS, there it is. It's this one here. And as you can see, this is the data that was deleted and then reinserted, which it does every night. Well, every time I run it actually. So as you can see, there's the last contract there, which is 2025-048. Okay, I don't see any more questions, Jonathan. If anyone's got any more questions, then if they'd like to post their messages now. Otherwise, that's the end of my presentation. So thanks very much for your time.
Right, indeed. No, I don't see any more questions. We'll just leave it open for a little bit longer, just in case. But thank you, Andrew, for that fascinating demonstration. Very interesting. Again, just to remind people, if you would like to see this presentation again, it is being recorded, so do get in touch with Rocket Software, but they will also do any follow-up that is required. Similarly, if you have any questions for Common Europe or would like to get involved in any way or need more information about our events, then please do get in touch. Use our office address, office@comeur, that's COMEUR.org, O-R-G, office@comeur.org. Right. No, I think there's a comment rather than a question there, Andrew, is it?
Oh, how does the licensing model work? Yeah, sure. Yeah, sorry, I didn't explain that. It's just by number of tables and targets. So if you've got 300 IBMI tables and you want to replicate to let's say SQL Server on Azure, then it's based on number of tables and then the target as well. Yeah, so it's not based on kilobytes of data. So some solutions are priced that way. We just do it simply on the table. So if you've got a massive table with 3.5 billion records, it's the same price as if it's the table with 100 records in it.
Great. Well, if there are no more questions, everybody, well, thank you very much for tuning in. And again, thank you very much, Andrew, once more. If there's no more questions, final call. Nope. That's everything. Okay, well then, thank you everyone. We'll sign off here, and thank you for listening, and hopefully hope you join us again for another webinar in the future. Anything else, Andrew, before we sign out?
No, thanks very much for your time, and have a nice day, and hopefully it's not too cold where you are. It's a bit cold in the UK today. Thank you.
I think everywhere. Yeah, thank you everyone. Goodbye.
Okay. Bye.